Hi, this is Thomas Beebe with XDB Systems. I'm going to talk about setting up SSL for Informix. It's a really key feature that I don't see used nearly enough. So I wanted to do a presentation talking about why you should use it and how to actually set it up and get going. So what are we going to talk about? A little bit of what encryption is. This is something you may be very familiar with, and maybe something you've just heard a fair amount and have heard your auditors talking about that you need to use more of. So we're going to talk about what it is, why you should use it. In particular, we're going to talk about it around Informix. However, most of this will also apply to any other applications that you may use that do network connections. Some considerations about how we use it. We're going to do the setup with GSKit. So this is the standard way that Informix has been doing it for a while. I know not everybody is on the latest and greatest version, so I decided to focus on the GSKit because that is the most widely available piece. It is also used by a number of other IBM utilities, so this may be applicable there if you're running something other than Informix. We're talking about configuring and connecting using a client, put it all together, get going end to end. We're also going to add a little bit because Informix and XC4, which didn't come out that long ago, introduced the ability to use the common OpenSSL standard. So now you can use either one, though I will tell you it definitely seems that they are trying to get everybody over onto OpenSSL. So if you're setting this up initially and you're on 14.1 XE4 or later, I would definitely go the OpenSSL method. So what is encryption? Again, you may be very familiar with this, but I want to bring it up in case you're not. The important part of it is it protects your data by actually encrypting it or encapsulating it with a bit of security around each packet that is sent. So rather than seeing things in plain text, it's going to be largely gibberish to anybody trying to intercept in the middle. I'll talk about a little bit more about what that actually means in a minute. There's a lot of different forms of implementations. The recommended best way and how Informix does it is using PKI method. If you're using a really old system, you might be familiar with the crypt command or some other methodologies of doing it. Those tend to not be as secure, which is why the PKI methods have really become the de facto standard. It does use more CPU to encrypt and send the data. As well as then decrypting on the other side. So you do need to keep that one in mind. You can configure it for whatever strength you need. If this is just simply sending, non-sensitive data, you just need to meet a standard and it's older hardware. Maybe go for a little bit of a smaller encryption key so it takes less CPU to encrypt and decrypt it. If you're sending banking information, credit card data, social security numbers, any kind of PII, or anything that may just be a company secret, you really want a strong key on that. May take a few more CPU cycles, but will be stronger if somebody gets access to the data in the middle. It's going to take far more effort to be able to break it. Most of the standards that Informix uses are the kind that NSA says that will take, tens or hundreds of years to be able to crack, and some it's, even more than that with modern computers. So you obviously want to make this as secure as is reasonably possible. So PKI, public key infrastructure. You have all used it. Anytime you go to a website that's HTTPS secured, you're using it. How it works is you have two keys, a public key that anybody can have. Doesn't matter who you are in the world, you have the public key you can hand out as you see fit. There's nothing secure about it. You can't use it to decrypt data. Then you have a private key. This is the one that is sensitive, that is server only. So you only, that's key should not be accessible to any other users. You shouldn't hand that out. It should be considered just like the keys to your house. This is something that you really want, only people getting in to have. So you have these two parts, and they'll communicate, the public key is used to encrypt data and then sends it, and the private key decrypts it. There's a bit more under the covers we'll talk about. The other part is the certificate authority. This is the piece that actually issues the keys. For our exercise, we'll actually self-sign and act as our own certificate authority. If you're working with a web page, for example, if you have self-signed certificates, you'll get a big warning message saying, hey, we don't know that we can validate this certificate, because those are out in the wild. Hopefully you manage all of your database infrastructure, at least in terms of keys. So Informix will play nicely with self-signed, but if you're running a certificate authority, you can use that to generate the keys that'll be shared out. So how Informix actually uses it. So what happens is the server sends the digital certificate to the client. This is the public key. The client has the public key. It generates its own, connection piece to be able to encrypt. It will connect to the server. The server will send a digital certificate to the client, and the client will then verify it. So it's using the two pieces, the public and private key, to validate that we are who we say we are, and that we can communicate. If it's validated, everything looks good to the client, it will create a limited use key. So in this case, it'll create a one-time key so that every other bit of encryption, that encrypted data that is sent across, is using this one-time key. So even if somebody were to get your private key midway through a session, they wouldn't be able to read what was going across the wire, because it's going to be using a different key for it. Obviously, you never want somebody having your private key, but it does limit the amount of damage somebody that's sniffing your traffic can do, because every different connection is going to have a different key pair it's working with. So again, the server will get the key, decrypt it to make sure that the private key is working correctly, and then we go, as long as that session is active, using those keys. So again, it's only known to the client and the server. If you have a different client that connects, it'll get a different single-use session key. So most of the time, your keys are only going to last a few minutes, if that. Makes it even harder for somebody in the middle to be able to listen to your data. So why is it actually important? By default, Informix sends everything plain text. System's been around for a while. It started out in the rhost telnet days, where everything's unencrypted anyway. Nobody had the spare CPU power to be able to do encryption end to end, so it wasn't that much of a focus. Also, in those days, most of your networks are fairly secure anyway, and you were generally dealing with things in-house as opposed to things external. Obviously, I'm generalizing here. There are lots of people that did other things with it and found other ways to do encryption. At the very end, I'll talk about some of those other ways in case they're useful for you. But at any rate, so Informix sends everything clear text, including passwords, by default. Obviously, you don't want that getting out there. That is the biggest piece you want to make sure is set. The next thing is you want to make sure the server you connect to is valid, that you can connect directly, that nobody is sitting in the middle trying to play with things. We'll do that digital certificate to make sure end to end we are who we say we are. Again, we want to avoid what are called man-in-the-middle attacks. This is when somebody sits there, takes your traffic in, basically pretends to be the database server, sits in the middle, takes your traffic in, does whatever, reads it, does whatever with it, or changes it for that matter, and then sends it along to the server. Because the data is encrypted between the client and the server, if somebody tried to sit in the middle, either to sniff or even to change the data, they're just going to be getting gibberish coming in and sending what the server sees as gibberish going out. So it doesn't do them any good. It also comply with many regulations. Auditors are becoming much stricter. Policies are changing. most companies out there, especially larger companies, now require encryption, which is really good. I am very pro encryption. Everybody I feel should be using it. But a lot of times, if you are not using encryption, you get a security audit you're not going to pass, or you're going to get a stern warning and then not pass your next one. Now is the time to go put it in if you're not using it already. You should be planning out the infrastructure. You should be planning out how you put this in and make it work with all of your applications. And again, the big thing is your data is encrypted end to end. So it doesn't matter if your client is sitting on the server next to it or even on the same server, or they're sitting, halfway across the world trying to connect through off of a, Starbucks connection, which anybody can sniff. You want to make sure that everything is encrypted, everything is secure. You're not having to worry about where your clients are, what the client, if the clients are in a different network that you don't control. You don't want to have to worry about that. You don't want to have your network security team, have to clean up messes because somebody was on an insecure network and then has gotten their data sniffed. So this is where you, as your DBA, or if you're listening to this and a network security person, you go talk to your Informix DBA and tell them to do this. Everyone at this point really should be doing this. Most of the considerations have been dealt with over the last several years. So let me show you the why you should do this. Why you should really look at doing this in a real world situation. So what I have here is two servers that are going back and forth. This is a standard, DB access connecting into Informix. Coming in from 10, 19, 49, 131, going to 130. What I have down here is a tool called Wireshark. This is a packet sniffer that will actually listen to the data and actually show you exactly what the packets are coming across here. So you can see where I have highlighted, it actually shows you the user connecting as Bob, showing you the password, information about the server, information about the connection, what they're coming in from. If you're not running encryption, somebody sitting on your network, whether this is somebody that is supposed to be there and just happens to be running Wireshark somewhere between your client and your server, or somebody that has broken in and is now, sniffing the data coming through. If they're watching this, they now have your username and password. If you're not running encrypted, they can now, if your server is wide open on the Informix port, they can now connect as you and do whatever you possibly have permissions for. This is obviously not ideal. So this is another little bit here. If you look at the bottom of this, you can actually see the select statement, select star from item, and you'll actually see the data returned. So you can see what's being sent, what's being returned. If you're going out there, select, SSL number from customer table where customer equals 5. This person's now seeing that, SSL social security number. You've now in all kinds of violations of security security practices, audit compliance, security compliance, all the other stuff. Obviously, as the DBA, you don't want this on your head. I know I am beating this into the ground, but really hear me here that you want to implement this. I really bring this up because I'm a consultant. I deal with many systems. I deal with many different types of systems, different infrastructures, different types of companies, different level of security. Many places are thankfully implementing this if they haven't already. A number have put in, that have been running Informix for quite a while, have put in alternative methods to secure, which is great. But not enough companies are using this. And I really want to put this presentation out there to go, if you're running a system, if it is not encrypted, please follow this along. It really doesn't take that much effort, and you can move on with life and sleep a little easier at night. So again, this is just what a little bit of, from this SQL statement, select star from items. This is the stores demo database. If you've worked with Informix, you've looked at this at some point. So we do the select star from, and now we can actually see the data coming back. So again, if this had socials, we'd be in big trouble. So encryption considerations. So we need it both, the setup both on the server, which doesn't take a lot of work, but we also need the clients configured for it. If you're using ODBC or JDBC, you don't have to do a lot to the connection. If you're using third-party drivers, you're going to have to look at their processes for how to encrypt. The encryption standards or the encryptions are methods are fairly standard. So even if you're using a third-party driver, you probably can get it to play nicely. You are going to have to use additional CPU on both sides. If you're running an old version of Informix, I mean really old Informix version 7, Informix version 9, there are, if you're chuckling to yourself and you're sitting there on 14, there are real companies and for real reasons are still using those old versions. The SSL implementation at that point used a good deal of CPU. I benchmarked it at one client. This was running version 9. This was running older hardware. It was about a 25% additional CPU hit when we were doing SSL. We then benchmarked it again, running on version 12 at that point on the same hardware, and it was about 4%. So they've made it better. All of our systems have gotten faster. We're dealing with 20 cores rather than 2. We're dealing with 4 gigahertz rather than 1.2. We are dealing with much faster systems. So a little bit of extra CPU, not a big deal for 98% of customers. Again, if you're running an old version of the CSDK prior to version 3, you're not going to get this to work. It also, if you're using third-party drivers like ADO-DB or some of the third-party companies that have put out Informix drivers, it may or may not work. You're going to have to look at the documentation. Another thing to consider is certificates expire. Generally, in a lot of cases, you're dealing with, if it's dynamic certificates, you have them up for 6 months and then they cycle through. If you're dealing with an environment where you don't have a lot of access to the client systems and you can't push out an update to them with a new certificate, you may want to consider going for a longer duration server certificate to push it out longer. Obviously, this is not ideal. However, because each connection does its own unique single session SSL certificate or SSL key set, it's less of an issue than if everybody was using the same keys. Obviously, if you can expire it, push out an updated certificate every X months, that's the best situation, but not everyone can do that. So in this talk, I look at practical, not necessarily ideal. The larger key size, so you can actually define, do you want a 1024-bit key or do you want a 4098 or anything in between? The larger the key, the harder it is to break, but it also requires more CPU because it's a longer bit of data that needs to encrypt and decrypt. So what supports it? Just a little bit more of the details. ODBC, JDBC, SQLJ connections, all those support it as long as they're coming from IBM or HCL. DRDA connections, so if you're using the DB2 unified driver, you can use that. The old SQLI, or shouldn't say old, but the SQL driver, if you're running close into the system. Same with if you're using ESQLC tools, they work with it. DB Access, you can use ER and HDR over it. All the Informix standard utilities will play nicely with it. If you're running Connection Manager, you can set up Connection Manager with its own certificates and have it act as a client for the server with that certificate. So both proxy and redirect will play nicely with it. If you're working distributed queries, they'll work with it. PAM will work with it. The developers have made a really good job of making this fully integrated with all of the different parts of Informix, all of the different standard client tools. So it really, in a lot of cases, simply a drop-in. You enable the SSL listener on Informix, you get the keys out to the clients, and then you can sleep at night and you don't have to do any more work on the tool. So IBM GSKit. So this is standard with the Informix versions before before 14.1 XC4. After that, it does still bundle it. It doesn't install it by default. So it is the primary utility before XC4 to set up and manage encryption keys for Informix. Again, a number of other IBM utilities use it as well. Does ship with both the CSDK and the server, so either one will give you the toolkit. It'll let you use SSL and TLS for the communications. DB2 use it as well. I believe they are also looking at OpenSSL. So the primary utility for it is GSK8 CAP ICMD. Not the easiest one to say out loud, but it's there. If you're running a really old version of Informix, you'll see the GSK7. Most anything you want to be running these days will be the GSK8. And we'll talk about OpenSSL options in a few. So a little terminology going forward. So the Keystore, this is a really small, or normally really small, file-based database of certificates. So this will be, if you're connecting to one Informix instance, it'll just be one file. If you're connecting, your client may connect to multiple systems, you'll have multiple certificates that all go into the Keystore. What it knows is this is the public key for the server and a little bit about where the server is, what to expect with the server. So when you make the connection, it'll look at the key store, it'll decrypt it, pull the information it needs, use that for the public key to connect out to the server. And the server will have its own key store that has its own keys, both public and private, in it. The second part, and this is an optional piece, is the stash file. This will be a secured file on your local system that will basically allow you to use the key store passwordlessly. If you don't have a stash file, you'll actually have to be prompted for the password for your key store every time. Depending on your security requirements, you can decide which way to go here. Most cases, if you have end user client applications, you probably want a stash file to be there and just be very locked down to only that user account. Because you definitely, or most cases, you don't want the users to have to put in a key store password every time they connect. Before then, they put in their normal credentials before they maybe have another set of secured credentials. It's one more level that may impede your user experience, but obviously depends on your environment. The last key term is the certificate. So this is the actual piece that holds the public key information. So you create your public or your private key, and then you'll create your public key based on the private key, and will create certificates based on that you then hand out to clients. So all the clients will have your certificate. They will all have that certificate loaded into their key store. So that's how their clients will actually know how to access it or access your server correctly. So putting it all together. So we configure our Informix server. We add an SSL listener to sqlhosts. So you need to run this on a different port than your insecure listener. What I normally recommend once you get your system put together is have your security team turn the firewall on and disable incoming connections to your traditional insecure listener and only allow SSL connections in. So that way you still have the unencrypted local listener. So if you need it for something, it is still there, but all of your client data, all of your replicated data, whatever you may have will come in over secure and not have the option to go insecure. You don't want somebody with some legacy version of your software still sending everything in clear text. So you add your SSL listener SQL host. We create our server key store. We create the server certificate. We're then going to create a file in your Informix dir/etc called conssl.cfg. This is both for Windows and Unix. They work the same way. And that will actually tell us where the client files are. We're then going to create our client key store. We're going to pull our certificate from the server and then import it into the client key store. And then, like everything else in the world, when you make a change, you want to test. The first test is you take DB access on the local system, make sure you can connect to the SSL listener. Then the second test is create a remote system, take the public key, create the key store, and make sure you can connect from there. So configuring the server, and I'm going to go step by step here. You can go back and watch this presentation. I think we'll put out the slide deck as well to go back and go step by step through this. Really, when you get down to it, you've done it a few times. It takes about 5 minutes to get running. I'm going to talk far more than this actually will take you in the real world. So the first thing is we may need to make sure GSKit is installed. If you've done something like just copied your Informix from another system to that one, you need to manually install GSKit because it will. It comes bundled in the Informix directory, so you can find the files under the GSKit subdirectory if you need to install it manually. Hopefully, you'll have everything installed properly and it'll be there already. You adjust your onconfig values, we update sqlhosts, we create the key store, and then we bring it all online. So on config, what we need to change there. The first thing we need to do is either create or modify, or if we need to add it, the SSL key store label. This is how the Informix server is identified. I'd recommend if you're running multiple Informix servers, you make this unique. For examples, we're going to be using IFX_encrypt. The next thing we want to do is add an SSL listener. If you don't do this, it'll create it automatically, but what you do is you add the net type, SOC SSL, and then the number of how big the network buffer pool you want. This works the same as your standard SOC, the SOC TCP listener configuration. The next thing is the VP class encrypt number. So this is actually going to create a new virtual CPU for encryption. Again, if you don't set this, it'll bring one up automatically. If you're doing most of your traffic through encrypted methods, you probably want more than one. And then we're going to go create a new DB server alias for our SSL listener. So we're just going to call it IFX_server_SSL. So next thing we do is update sqlhosts. There's nothing too scary here. We're going to create our one for our DB server alias, so IFX server SSL. Rather than onsoc TCP that I'm sure you're familiar with, we're going to use onsoc SSL. Then we give it our server name. So this is whatever IP we want to use, or whichever port, device on the server we actually want to connect to, so whatever IP on the server, and then our port number. So this works just like every other SQL host entry. The only difference is onsoc SSL. So to create the key store, we're going to run everything in Informix dir/SSL. This is a secure directory. We want to make sure this is not widely available. Again, we use GSK 8 in most cases, 7 if it's a legacy system. If you're running a 64-bit system, which most of us are these days, you'll actually do the same command with _64. And again, our DB server name is IFX server. The SSL is IFX server SSL. The key store label here is going to be IFX encrypt. So remember we set the key store label, so IFX encrypt. So we'll be using that through. These can match your DB server name if you want. You can also have it unique, whichever you prefer. The big thing to keep in mind, your DB server name, so IFX server, must match the file name of the key store and stash. If it doesn't, when you bring the engine online, it'll fail, giving you a can't find key store error. So we're going to create the key store. So we're going to use the GSK8 CAPI CMD 64 command because we're running on 64. We're going to create a new key database. We're going to give it the local server name, IFX server KDB. The KDB I just want to highlight here is for 14.1 FC4 and earlier. The newer versions, 14.1 FC4 and later, they want you to use P12. It's the same command, but it is telling it is the newer style of key store. It's just standardizing on modern methods. Then we give PW and the password. We're telling it the type CMS, so it's the certificate type. CMS is standard for Informix. And then we give it the stash, so it knows there'll be a stash file with it. So we've created the key store. Now we're going to create the server cert. So we're going to do the same command, but we're going to tell it with -cert create. So we're going to create a new certificate. We're going to tell it the database that we just created, the IFX server KDB. We're going to tell it it's stashed, so it's supposed to go into the stash file. Then we give it labels. So this needs to be the SSL Keystore label from onconfig. We're going to give the size. So in this case, it's 2048. I really wouldn't recommend less than 1024. I'm not actually sure Informix would let you do smaller than that. Most of the time these days, I would do 2048 or 4096. Just if you want to make it stronger. Then you can give it the default cert. So this is it the default certificate to the server? Most of the time, because we're creating a certificate for the server, we want that to be the default. Then we give it the expire. So remember I mentioned that the certificate expiration date matters. If it expires, we're not going to be able to connect from clients. So if you can push out new versions of their certificate or the key store to clients, you want to make it small and make it sure the push out will match the expiration or the updated certificate. You can have multiple certificates for a server, so you can or cycle through certificates on the server just with a different label. So you can work with the clients to have the old certificate and the new certificate. And when you're ready to update, just change Informix to the new certificate label. And then however, if you're in a situation where you don't control the client systems, you don't know when you could push out a new version, maybe you want the expiration to be longer. Maybe you want it to be 3 years or 5 years. Not best practice, but real world, you may need to. Then the last thing is the DN, which is just telling it a unique identifier. So in the certificate, if you inspect it, you'll actually see that identifier. This can be really useful if you're running multiple servers to get a better idea of, okay, this certificate matches to this server. You can give it a very descriptive name. It doesn't tie back to anything else. It's just a little bit of text in the certificate. So continued. Again, I wanted to add the extra flags there as the red text, so it's there. Next up is we're going to have two files. So we're going to have, excuse me, IFX server STH, which is our stash file, and the KDB, which is the key store database. For Informix for the server, have these be 600. This is our private key. These are the keys to the house. You don't want anyone else on the server having access to this. So now we've got our server set up. It's now the key store set up. We've set it sqlhost. We can bring the engine online, and it is going to have that SSL listener running. So now we want to set up the client key store. So we use the same command. We're going to create a new key database. This time we're going to call it client db.kdb. We're going to give it a password. We want this to be a different password from our server. We're going to tell it to stash also. The second thing we actually have to do is extract the certificate from our current server. So what the server is going to do, we're going to tell the server key store, to actually extract the public key and turn it into a certificate. So this big long command at the bottom, we're going to cert extract. We're going to tell it to use the server database. We're going to tell it to put it in ASCII. We're going to tell it which label to use. The label, again, is needed in case you have multiple certificates in that key store. We're going to give it the server password, and then we're going to give it a target of this is a plain file. We usually call it .cert. This is a plain text file. You can pass this around as you need to. You can feel free to open it. It's just a big long string of numbers. You can, if you're really interested, you can dig into tools that'll actually let you view the different bits of information in it. There is nothing sensitive in that certificate. Obviously, you don't want to put it on the internet just for anybody to have, just so you don't want them to even be able to start the connection. But it is not what I would call a secure or sensitive bit of data. So we're now going to add that certificate we just extracted to the client key store that we created. So we're going to tell the command again, we're going to take the certificate, we're going to add it to the database for the client database. We're going to tell it stash, we're going to tell it the label it's expecting, the file it's coming from, and again, that it's coming in ASCII. So the next thing we need to do is create this conssl CFG file. Can't put it in another directory. You can't call it something else. This is where it has to be. It doesn't matter if it's Windows or Unix or anything else. It's got to be informix/etc/conssl. So our keystore file is going to be, tell it where that file is. The stash is going to be the full, and these need to be the full path, path to the stash file. In most cases, you will want these not to be an SSL. I just put it there for convenience for this presentation. Most times you'll want this to be in, let's say, the client's home directory. Some people put it in the Informix directory /etc, which is world readable. You want this somewhere to make sure the client application and the client user can access these files and read these files. So we've created our server SSL information. We've created our client SSL information. So our next steps. Again, we bring up the engine on init, obviously with -v, make sure everything comes up cleanly. You cannot use onmode-p to start SSL listeners. That's thrown a number of people in the past. If you're not familiar with onmode-p, it lets you start or stop listeners. You can't do it with SSL. You can make sure that you can connect to your standard TCP ports with DB access. I always recommend this. Make sure you didn't just lock yourself out of the system with the SSL implementation. And then take DB access. It'll use your client client information in Keystore automatically. Make sure you can connect to your SSL ports. Make sure the whole thing works. Then we take, we've tested local, then we take our Keystore credentials, take our cert, pass it on to any other clients we want to have them create their Keystore database, have them create their stash file, and then they'll be up and running. And make sure to have them point to the OnSoc SSL listener port and change the connection settings. Hopefully, you have an application. If you're dealing with many clients, you can just make that change and push it out to them so you don't have to do it one by one. If you need to do it one by one, it will be worth it after you're done with the whole process. So configuring Windows, because a lot of times we're going to have Windows clients. So we want to create a directory where the Keystore and stash files can live. Some people put it in your Informix client SDK directory /SSL. We're going to use :/SSL. You may want to put this with your application. It just depends on your environment. So we're going to, if you're using multiple versions of the CSDK for one system, make sure your conssl file is in every one of those CSDK directories. Then we do the same thing with SSL Keystore file and STH. We give them the full path. It needs to use DOS formatting. So if you're dealing with directories with spaces in them, like program files, you need to use the DOS formatting. So it'll be, ~1, ~2, what have you, out to the directory you need. So copy your IFX server cert from your server to the directory you want it in. You need to run this as administrator, otherwise you get some errors, but you want to be at the command line. So we're going to add our GSK8 bin directory, your path, if it's not there. If you're doing this frequently, you may want it in your environment. I will also mention you can generate your Keystore and stash files on a remote system and just copy them over. All depends on your environment. So we're going to set our path. We're going to run the same command we did on our Linux box. Just now we're adding a .exe, create the client store. We're going to import it, make sure to use the right label. We're going to import the certificate. And now we have our file and stash file. They're done. Don't have to do anything else. For a Windows connection, we're going to set up an ODBC. Just make sure to use the OnSoc SSL and the DB server aliases for your SSL listener. And obviously the port number you define for SSL, and then test. So OpenSSL. So again, this came in FC4 and also in Client SDK 4.50 XC4. You can use a mix of GSKit and OpenSSL. They also have the ability to migrate your certificates and your keys from GSKit to OpenSSL. This really is the way of the future for it. If you're doing this initially, I would really recommend. I just realized I made a typo. It should be 14.1 FC4. I will get that corrected before this goes out. So it's by far OpenSSL is by far the most used SSL system. It's been using Informix has been using the OpenSSL libraries for a very long time under the covers, but just now they're implementing it so you can use it with client server connection. Incredibly widely supported. I don't know any different operating system that does not have OpenSSL available. It's better certificate management. If you want to use a standard certificate authority outside of the local server, it will let you do that very easily. You do not need GSKit installed for OpenSSL. The client SDK will actually prompt you if you want GSKit or not now. So enabling it. You create the private key pair, same way, you just use the commands to do it, create a self-signed certificate. We're going to create a PEM file. That's just the standard file name for OpenSSL, but it'll have both our certificate and the information about the self-signed, and we're going to combine them. We're going to create the key store based on that. We create the stash file. We're going to create SSL keystore label and the onconfig, and then we'll bring the engine up. Pretty much the same process, slightly different commands. So OpenSSL, this is the step-by-step to do server setup. We use gen RSA. We're going to tell it the server key.out. So this is actually going to generate our certificates and our local CA effectively. We then request a new key. So that's going to be called server key.pem. Obviously, these file names can be whatever you want them to be. We use subject and then CM, and then let's say the server name. This again is your descriptive piece. It's in there for text. It doesn't really matter what you have set. We're going to give it the number of days that it should live. In this case, I give it 3,000. So we're dealing with 8 years of the certificate being valid. And then we tell it the out file. So we're going to create the the server certificate.pem. We next do a cat file. So cat, server key, and then our server certificate. So we're combining both of them into a single file that'll be imported to the key store. The next thing we do is we actually create an export file, which will be our key store. We're going to tell it to bring in the import file. We're going to tell it the label to use, which should match the Informix label. The SSL label. We get pass out. So this is how we're doing the password. In this case, I use pass : and then our password. So ABC12345. Please do not use that password. And then we're giving it the out file. So we're going to pull in all the data and then output a single P12, which is our private key. Then we use onKstash. So we'll actually give it the file name and then the password. And then we're going to say, and just as a note, our SSL key store label in this example is server SSL label, same as we had in the import export command. So that's what we need. We now have our files for the server. We're going to have a server1.p12 and also have a server1.sth. I did a live example here, same commands as you saw in the last one. Have my server called Llama. It's a long story, but we've created our files, our PEM files. We've created our key store with the password. We've created our stash file there. And when you see in the middle, the LS, you'll actually see our files, our old PEM files, our stash, and our certificate. You do not need to save the PEM files. You may actually want to delete them or move them to a very secure location because they have your private information in them. What you do with them is up to you. So we bring our engine up, and then using onstatg NTT, you can see we now have on the first line 9098 SOC SSL. Our listener is up and running. We're good to go from the server side. So our client side, similar as we did with GSKit, we import or we use the server value of P12 to actually export the certificate. So we're going to call it keystore label.cert.pem. Obviously, replace keystore label with whatever your onconfig keystore label is. it just makes it easy to tell which certificate you're working with. We're going to copy that file over to the target system. We're going to say we're throwing it in the SSL directory. As before, put it where you want it. We're then going to do the same process as we did when we imported the PEM files. For the server, we're going to import our server name certificate file. We're going to tell it the CA name. So this is the actual server name that we're connecting to. We're going to tell it no keys. So this tells it to use the not embed a separate password for this. And again, we have the export out for the client P12. So our end file is going to be client P12 and client.sth. We set up on SSL the same way as we did before. What's recommended is you set the client files to the stash file and the P12 file to be chmod 666. We want all of these clients on the server to be able to access the SSL listener most of the time. If you do not give that permission, by default, it'll be 600. So you'll test it with one of your clients and suddenly you'll get a bad key file or can't access key file kind of message. It's because it can't read it. So make sure to set your permissions properly. You can have a client keyring with multiple server. So just that's where we use the labels to differentiate. You can reuse a client keyring. Not ideal, but doable if you need to. So the same stash file, the same P12 file, you can copy those between different systems. I found it even works between different operating systems. Recommended deploy it individually, create the key store for each system. But if you have to roll something out with an application, it's an option. So again, just make sure your permissions are such that your key store and stash files are readable by all of your clients that need to use them. So alternative options. If you can't use SSL for some reason, you're running an ancient version of Informix and don't have the horsepower, you've got some reason why the application can't use it. You're using some third-party driver, or if you got CSDK from like version 2 or from 2001 that's tied to your application. There are reasons, not a lot of them, but there are legitimate reasons you can't use it. So you can use the Informix CSM. I don't go into it here. It is a way that it will allow you to encrypt. It's been around for quite a while, should work with most of the older drivers. Will allow it to encrypt the login and password. Doesn't encrypt the data going across, but at least will encrypt that bit. A really good one is permanent on-demand VPNs. If you make your clients, all of them connect as a VPN that just goes to your database server or to a very secure network around it, all your data is going to be encrypted. Your password being sent, everything else will be encrypted in this case. It mostly works best when you're dealing with an application server, not users out in the field. But even them, if you've got that end-to-end VPN, that covers you most of the way. An SSH tunnel is the way I've seen it done. You can create an on-demand SSH tunnel between two systems. Again, this is a case where really I wouldn't do it for clients. You could do it for an application server, where basically anytime either a permanent one is in place or anytime a request is made, it recreates the SSH tunnel or makes sure it's online, and will actually pass all the traffic through that. You can set up a second network device that only connects to through that SSH tunnel, so no other traffic goes through. It's an option. Simple password, it works with the CSM to do the password encrypt or the secured password. Using a mixed environment of all of the above to secure it more. Again, if you actually add in a central certificate authority with OpenSSL rather than a self-signed certificate, it adds a little bit more control. So it is just another option. Again, 98% of the time, using SSL built in with Informix will be your easiest and most secure option. You know it will always work. If you turn off your standard TCP listeners, you won't allow your clients to be able to connect or firewall block them. So you don't have to worry about insecure connections coming through. So I wanted to link this. The IEG had a great talk back in 2020. actually going for migrating from GSKit to OpenSSL. So if you've been working with the GSKit environment and you want to move to an OpenSSL environment, check out the talk. It's a webcast, runs about 40 minutes, does a really nice job of walking through the commands to take your GSKit key store, bring out the data, bring it into an OpenSSL one, and be ready to go. So a little bit about us is we do a lot of consulting, pretty much any version of Informix you have. We offer 24/7 monitoring and remote DBA services. We, do a lot with upgrades, migrations, really anything you need Informix wise or around database support, let us know. Again, thank you. We're going to hop to questions here in a moment. Thank you very much for being on this, or thank you very much if you're watching this in replay. If you have follow-up questions or problems, feel free to reach out to me. The IBM the Informix section of the community portal is a really good place to ask questions as well. I'm trying to keep an eye on there for any SSL ones that come out. So let me know, and if you really found this useful, let me know that too. I always like to hear how people use it. So I'm going to go ahead and stop sharing now. So, all right. See, does anyone have any questions? I'll give this another minute. I can't actually see the participants, so I don't know how many we have in right now. Oh, Tracy, any other questions? No worries. I got a note that no questions. Great. Hopefully this was incredibly useful. If you're watching on replay, I know a lot of the webcasts, it makes it much easier to watch it after the fact. So I know this was also early if you're doing West Coast. Feel free to email me. Emails at the front and back of there. I believe contact information is in the session info. So reach out. Tracy, anything else we need to do here? So Tracy's are fantastic moderator, by the way. So really appreciate this. So thank you all very much. Again, if you have any questions, please let me know. Thanks.